Well, hello, ladies and gentlemen. It's Mr. Green again, and we're doing another in our lessons in Unit 3. We are looking at uh, functions that are a little bit weird today. One, you're going to look at it and go, I've never seen a function like that before. But what we're going to be talking about is called step functions, okay? A step function, you're going to be able to draw it or describe it if you see it, and evaluate a step function for a given value, and write a rule for step functions if given the graph. Now, the reason I say this is a little weird, because what we're looking at is a piecewise function with tons of little pieces in it, right? Well, each one of these pieces is exactly 1 unit long. That's why they're calling it a step function, is because it's actually just a 1 unit wide domain for each one of these, okay? And we could be sitting there writing all sorts of domains on this one for a long time, but they came up with a nice little way for us to write this one, okay? What they're doing is it looks like they're writing an absolute value function. But notice how it's in italics and it's slanted to the right a little bit. I want you to also notice it's got a floor written under it. See how that little line is written underneath it there? That means graph the function f of x where the floor is over. Okay? So what are we looking at? We're looking at where the graph is actually equal to whatever the value is, and it goes out here and it has this open circle at the top end of everything. Okay? So at 2.6, this one would be what? Well, we're looking for the floor of it. So let's go here over 2.6, and it goes all the way up to here. The y value in this situation is going to be 3. At -2, I'm sorry, -3, because that was at -2.6. -2.6 would be right down here. Okay? At -2, what is the value? Well, it goes all the way down. It stops right there at that point. It'd be -2. At -1.3, what would it'll be? It'll be -2. Because at 1.3, that'd be right in here, and it would hit right there. Okay? At 0, what's it going to be? It's going to be 0. At 0.7, well, that's right in here. And guess what? That's still going to be 0. At 1, what's it going to be? If I go to 1, that's an open circle. It's not going to be that one. It's going to be all the way up here at that one. And that's going to be a 1. At 1.2, what is it going to be? At 1.2, you go over to 1.2 and up, you're going to run into 1 again. At 1.5, what's it going to be? 1. At 1.9, what's it going to be? 1. At 2, what's it going to be? 2. So we're finding what these are, okay? This is called the greatest integer less than or equal to the real number in an interval, okay? And I want you to notice, see how it's got the little line under the bottom of the symbol here, okay? So what we're writing is a symbol like that with a floor underneath it, okay? And so what we're looking for is the greatest integer that is over whatever number we're giving in here, whatever value x we're getting, whatever greatest integer over that one up to and staying within the range. Okay, well, that's a little bit interesting. Let's look at what happens when we look at functions like this. If we use a generalized formula, we put a value in front of it, just like we've done before, and we put a value behind it, plus k. Well, the plus k is going to tell you how far it's going to shift up and down. Okay? This value in the front here tells you what's going to be multiplied times it, and it's going to be like 1/2 one here. It goes at the half intervals, and at 2 times it would be 1, and at 3 times it would be at 1.5. Okay, that's how we can get these type of piecewise functions in here. Now at the floor function plus 2, it's going to be shifted up 2. So instead of being at 0, it's going to go up 2, 1, 2. And that's where my 2 point is going to be. At x floor function minus 3, you go down 3, 1, 2, 3. And that's where my solid point's going to go. Okay, I hope you can see that we're just shifting this function up and down with these k values. Okay, and we're using this one in here as a multiplier to multiply times the value and see what the y value is going to be. Okay, so let me phrase that again. This a value in front would help you reduce it down instead of being an integer. So if you wanted it to be like a half or a third or a fifth or something like that, you could actually reduce it down by using that multiplier in front. But it's still only 1 unit wide. Okay? So let's go on and look at the least integer function. That one was the greatest integer function. This one's the least integer function. And the difference between this one is instead of having a floor, we've got a ceiling on it. See how it's got the little line at the top like that? So it's got a ceiling on it. So that means we're looking for the least integer that would fit into it. So let's look at -2. If I go to -2, the least integer would be down here at -2. That's pretty simple. If I go to -1.8, you go down here, I get to -1. If I go to -1, what do I get? I get a -1. Let me move my little thing out of the way because it's obviously blocking my view, so it's blocking your view. So if I go to -1, it goes down, it gets the solid point here, it's a -1. If I go to -0.03, -0.03 puts me right in here, and so I'm going to be at 0. At 0, I'm going to be at 0. At 0.5, I'm going to be at 1. Wait a second, this is looking a little different. At 1, I'm going to be at 1. At 1.6, I'm going to be at 2. And at 2, I'm going to be at 2. Wait a second, what's the difference between this? I want you to notice where the solid points are. The solid points in this situation are at the right side. And the solid points on this other one over here were on the left side. So the greatest integer has the solid point here and goes to the open circle going to the right, but the least integer has the solid point on the right coming to an open circle on the left. That's how you can tell them apart, okay? Easy enough to tell them apart by looking at them that way. So I want you to recognize this one has a family of things as well. The A in the front, that's simply going to multiply it times it so that you can get things less than 0, okay? You can get things that are in the y values that are less than 0, like 1/2 and 1/3 and 1/5 and things like that. Otherwise, this k is going to shift it up and down. That's all it's doing, shifting the thing up and down. And you're just going to add that k onto it to find the new point. Okay? So let's graph this one right here over the range -3 to 3. So I'm going to have -3, -2, -1, 0, 1, 2, and 3. And just to make certain that we're not totally confused, -1.5 and 1.5, just to throw a couple of extra values in there. Okay? So this one is the one that is the lines at the top. So what we're going to do, at -3, 1, 2, 3, it's going to be down here at 3. 1, 2, 3. There'll be a solid point right there. Okay? So let's look at this. If we're looking at the ones with the lines at the top, we back up and we see that the ones with the lines at the top have the solid line with the open circle going to the left. Okay? So there's not going to be one there, but my next one is going to be obviously right here, going like that. And this one's going to be right there, going like that. And the next one's going to be right there, going like that. And the next one's going to be right there, going like that. And right there, going like that. See how I'm getting these? And right there, going like that. And I'll stop right there. Why am I stopping there? Because that's at 3. And this one's at -3. And we have graphed it all the way across. So at 3, my value would be 3. At 2, my value is going to be 2. At 1, my value is going to be 1. At 0, my value is going to be 0. At -1, my value is going to be -1. At 2, my value is going to be -2. At -3, my value is going to be -3. But the question is, what is it at -1.5? At -1.5, I come in here and I get down to right there, and I get a -1. At 1.5, what is it? At 1.5, it comes in at a 2. Okay? So that was the graph of this one right here. What about the graph of this one over here, which is the one that's the floor? Well, it's going to look kind of different, isn't it? At -3, I need to change colors here to something else so that we can see it separately. Okay? So at -3, it's going to be an open circle with a line going back this way, an open circle with a line going this way, and an open circle with a line going that way, and an open circle, a line going that way, and an open circle, a line going that way, and an open circle, a line going that way, and we'd stop right there. Oops. My pen tool disappeared. Thinks I was through with it. I wasn't. Okay? Open circle, line going that way. Okay? And we would stop right there. Can you see how I'm quickly finding the differences between these two? Right? Okay. So let's move on. Looking at this one, this is a floor one. That means at -4, there's going to be a point. 1, 2, 3, 4. 1, 2, 3, 4. Right there. One solid point. At -3, there'll be a point with a circle coming back this way. Open circle. Open circle. Open circle. Am I graphing the right one there? No, I'm not graphing the right one there. Sorry. Try again. This one, because it's got the floor, I'm going to go to 4. 1, 2, 3, 4. 1, 2, 3, 4. Point right there. Pen. You and I are going to have fights here. 1, 2, 3, 4. 1, 2, 3, 4. Right there. Okay? And then this one will be point, open circle. 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 2, 3, 4. That's what it would look like. Okay? Looking at this one right here, I'm seeing it's going point, open circle this way. That means it has to be the one that has the floor on it, right? X. But it's being shifted. How far up is it being shifted? 1, 2. So I'm going to say plus 2. Okay? So let's just scan back here. Just see that Mr. Green knows what he's talking about. Okay? So let's see here. Let's see here. This one has solids and open circles to the right. Oop, it isn't. It's the one that has the lines at the bottom. Yeah, that's what I got. Lines at the bottom. And it went up 2. Yeah, that's exactly what I've got. It went up 2. Okay? So let's look at here what I'm looking at. I'm looking at this one right here. Okay? Up 2. It's this exact graph right there. No, it's not. It's backwards from that one. See? Mr. Green's even confused by these. Easy to get confused by these, okay? Try again. It's this one. Like that. That's the one this is, okay? And I'm going to show you that one right here. It's this one right here. Okay? Well, that's why I'm confused. Okay, excuse me, guys, while I figure this out. Okay? I had it right the first time. I thought I knew what I was doing. But, you know, that's always questionable. When I start second guessing myself, just like you do sometimes, it turns out to be wrong. So this is the one that looks like this. Okay? Because my circles start solid and go to open circles, going this direction, right? Doing that, that's going to be this one right here. Okay? So, nope, it's not this one right here. It's that one. Solid circles going to the right, like that. That's what the graph is. And it's going up 2, because it's going through that point 2, 0, or 0, 2. And so that's where I got this up 2. Okay, moving forward. So, the one that looks with the one at the top, okay? See the ones at the bottom? Go to the right. So this one would be here, solid here, going 1 unit that way, open circle. Solid here, going that way, like this. Solid here, going that way, open circle. This one has got it at the top. It's going to do the same thing, except it shifted up 1, okay? But I got 3 times that number, so it's going to actually be shifted up 3 more. Okay? So it's going to have a solid here, open circle going this way. Okay? The next one is going to be right here. Solid here, going that way, open circle. Solid here, going that way, open circle. Okay? What did I do? I'm multiplying it by 3. So if my answer at 0 is 1, multiply it by 3, I got 3. If my answer at 1 would be at 2, I multiply it by 3 and I'm up here at 6. Okay? So it's just 3 times greater. Moving on. I just want you guys to know this is a confusing little bit. Okay? These functions are something that you're going to have to understand and be able to recognize. Now, whether you recognize them with the line above or the line below, you're going to have to just find some way of memorizing that. Obviously, Mr. Green has a little bit of dyslexia and can't tell them apart one way or the other sometimes. Okay? I am not going to tell you that I'm any better at it than you are. If you get confused by any of it, bring it to me in Toga and let's talk about it. I really want to talk about these, make certain you're understanding them. They don't occur often, but they do occur, and you need to make certain you know how to do them. Okay? And you will see them on tests and things like that. Remember, lots of times when you're talking to me, make certain you're telling me what course you're in, Algebra 2, or else I will have a trouble answering your question. Okay, talk to you next.